Good. Let me share my screen then.
Very good. Are you joining us from France?
Yes, I am. I'm currently in Paris.
Ah, very good. This time I would be
Yeah.
right with Paris.
Okay,
Looks
everyone can
great.
see my screen properly?
Amin, the stage is yours.
Okay, thanks a lot. Thanks a lot for the invitation. I really appreciated the organization overall and the opportunity to present our company called Hummink. Basically, today I'm going to focus on presenting a little bit the technology, which is called HPCAP. It stands for High Precision Capillary Printing, and we like actually to call it the smallest fountain pen in the world that gives you submicronic precision design. In brief, Hummink is the leading developer. We are the inventor of this technology that is HPCAP, that is mostly dedicated to display and semiconductor industry. We are a spin-off from École Normale Supérieure in Paris, and we already have representatives in Korea, US, Taiwan, Japan, and Europe in general. So the company was founded in 2020, and we're very proud of this. We already sold R&D equipment to several players and R&D departments, basically, and also ongoing discussions with tier one equipment makers to scale up the technology and reach high volume manufacturing capabilities by 2024. And this is actually the main goal of our technology. Our aim is to take an additive manufacturing technology and bring it to high volume production. So that's why we consider ourselves as technology providers that are able to enable the customers to have access to both equipments and inks throughout a single partnership. So we bring the technology and the know-how. So I'm going to show you a video about how the technology works. I think that summed it up. Initially, we have this tuning fork that is oscillating, and there's a glass pipette that is fixed on the tuning fork, so that resonates like this. It's a little bit like atomic force microscopy for those who know. So you bring the pipette close in contact with that, and you have the tuning fork that resonates at its resonance frequency. And once you come in contact, there's a liquid that is filled inside the glass pipette that is going to form a little meniscus between the substrate and the tip. Hence, the frequency shift is going to change. And we monitor that. And this is the strong basis of our knowledge. Once you take the pipette back up again, it comes back to the resonance frequency and so forth. So there's no pressure, no UV, no laser. It's direct printing technology. And we constantly follow the topography of the sample. So it automatically adjusts to any surface roughness and topography. You have unprecedented freedom of design. You can print basically any ink. We're working on also multi-tip options. This is also an application where we are extremely good. We have a unique positioning precision capability because we deposit the ink only where the pipette goes, so we don't have any satellite drops or something like that. So once you have a repair application that is required, you come exactly to the position where you have a missing link, and you contribute to actually fixing that. So this is somewhere where we're actually very strong. The resolution ranges from 100 nanometers to 50 micron just by changing the diameter of that glass pipette that I was showing you that was oscillating. And as there's no UV, no laser, it's strictly the strength of capillary forces, we can go up to 100,000 centipoise, which is quite a lot for this type of resolutions, and basically print any ink. It's very easy to change the tip. You fix it back on the tuning fork, and then you're going to be able to print. So this is also a vision of what we are working on. We are working on getting a module that will be able to be integrated in the production lines in the display and semiconductor industry, and we do that on demand. So since the video worked, I don't have to show you the slide, but overall what we are capable of doing with this technology is basically really printing any material that takes the shape of an ink. We have printed the basics of electronics, silver, copper, gold, exploring also capabilities with graphene, printing basically any polymer possible. Display applications come with quantum dots, so we also have done that. And you can do that on any substrate. And here's just a few images of the capabilities that we have. If you look at the scale bars, you can really see that it is micronic and submicronic capability.